This is Srikanth Vengadala from Whitson. So for today's Tip Tuesday video, I want to talk about autofitting options, some of its merits, benefits, limitations within the decline curve analysis module of Whitson Plus software. Okay, before I do that, let me know how many of you guys remember this wonderful, funny TV series called Small Wonder. It was aired back in late 1980s, but I kind of ended up watching in late 1990s. So here's a funny scene. Ted Lawson, who over here asks his daughter at a dinner table saying, "Hey Vicky, could you please pour over the coffee for me?" And then Vicky says sternly, "Vicky pouring over coffee." And then all of a sudden conversations continue, and after 1 minute, Ted Lawson realizes that his pants are actually burning. That's when he realizes, "Hey Vicky," he says, he starts realizing and yells at the top of his voice saying, "Hey Vicky, stop, stop, stop." That's because Vicky is actually a robot, and then he has to give clear instructions to actually terminate the action that Vicky was doing. Here's another funny scene, and the mom this time asks Vicky, just after the dinner table, right after having the dinner, just drop those dishes in the sink. And Vicky literally drops all those dishes from about 3 feet high, ends up breaking all those dishes. That's when they realizes, okay, this time we better give clear instructions to Vicky to make our lives easy. So the moral of the story is any automation option within any domain, you have to understand the kind of clear-cut boundaries within which it operates, right? So we have a similar function within Whitson Plus, a great function called Autofit. And in the decline curve analysis module, it lets you fit those segments beautifully over the production history behavior, right? So today, let me show you some of those constraints and those boundaries within which that Autofit function actually works. So here's the software, Whitson Plus, and here we have a gas well which is produced for about 2 years approximately. And now this is the auto fit button at the top. So if I kind of press that button, so let me just see what happens. And if I just do that, it's going to fit my decline, which is the black curve, on top of that production behavior. And it is a pretty good fit, right? And I've seen my B factor is about 0.791, which is good. But somebody told me, this is in fact a relatively new well. It's a hydraulic fractured well. It's still not as experienced in the boundary dominated flow because that person has already done the rate transient analysis RTA, and he's seen that it's mostly in the linear sort of flow behavior. So which we know that the P factor is actually between 1 to 2, definitely greater than 1, right, within this flow regime. So if I have to impose those sort of constraints to my decline curve analysis, I cannot press a lock button because I still am not certain about the kind of one particular value of P factor. I want to give it a range. So what I would do is this is a clearly overlooked option, but I would be pressing this button, which actually lets me edit some of those auto fit settings. And by hitting that button, for the ARPS decline segment specifically, I can have some additional constraints imposed on that decline curve fit. So I can see the peak rate production ratio, which acts like a multiplier applied to the observed flow rate at the peak rate within the decline curve fitting range. And that can be about 20% higher than the peak rate or 40% lower than the peak rate. I can also impose constraints on the nominal initial decline rates and also the P factor. So for now, this exercise, let me do a range of the P factor. Let me say from 1 to 2 rather than having from 0 to 2 as a default. And I would also impose my peak production ratio, peak rate production ratio to about 10% higher, not about 20%. So let's say 1.1, I hit save. And now if I do an auto fit, what I see is my P factor has converged to a value of 1.005, definitely greater than 1. And it's a good fit. It's definitely a good fit that I have over here. I'm still not completely happy, right? So this is a single segmented decline, but I can see that there is a flat sort of a behavior towards the beginning. And so what I would try to do is maybe add one more segment and let's see how the autofit function kind of works over here. So let me add one more segment at the beginning. And for the first segment, I want to give it a semi-log because it's a semi-log plot right now, I can see. So let me give an exponential semi-log for my segment 1. And I would move my initial rate. I would try to impose my final point on the segment 1 to be right over there, which I'm supposing where the flat curve ends. And I'll try to move my segment 2, which is the ARPS decline. I'll keep it as an ARPS decline. I'll align my end date for the decline segment to be the end of the production. So I would hit this button that would align my last point over here on the black point, on the black curve, to be at almost the end of the production behavior. And similarly for my segment 1, I would hit the start date to be the beginning of the production by hitting that button. Now I'm happy, so I can hit the auto fit function. And once I do that, I have three options, and I can do the auto fit on all the segments, or just segment 1 or segment 2. I would hit all segments this time and see how my auto fit curve behaves. Voila. I'm pretty happy with what it's doing. So within the constraints I've given already imposed to it, my B factor is from 1 to 2 during the up segment, and then it's also aligned, giving me a good fit on my segment number 1, which is a semi-log plot. So hope you guys enjoyed and like some of these tips for doing and for implementing the AutoFit function. And let us know in the comments below on how you kind of enjoyed using this AutoFit function, and what were your experiences while using this functionality in Whitson Plus.